Every autumn, millions of tons of freshly harvested crops are carefully poured into massive commercial grain silos. It is easy to look at these giant steel vaults and assume the work of the harvest is finished once the heavy doors are sealed. Unlike sand or gravel, every kernel in this bulk is a living biological organism. These organisms constantly shed residual heat. Almost immediately after the grain is placed in storage, dangerous temperature differences develop deep inside the center of the mass. Left unmanaged, the interior of a silo becomes a volatile microclimate, capable of destroying its contents. Heat trapped in the center of the grain mass naturally rises, pushing upward until it meets cooler pockets near the steel walls. Here, condensation forms. This trapped moisture creates expanding hotspots of intense heat that quickly spread through the grain. These active hotspots trigger dormant insects and allow microscopic mold spores to bloom across the damp kernels. Left unchecked, this internal weather system can rot thousands of tons of crop from the inside. Protecting the harvest requires stopping this internal weather system before it has a chance to form. To manage this internal environment, commercial agriculture uses grain aeration. Aeration is the controlled movement of air through stored grain using specialized fan systems. While it uses high-powered fans, aeration is not a method for drying wet grain. Grain must reach safe moisture limits before it ever enters long-term storage. Drying prepares the crop for the bin. Aeration manages the temperature once it arrives. The process relies on massive fans to slowly push or pull ambient outside air through the entire grain mass. This is a matter of timing. Aeration is effective only when the outside air is cool and dry enough to flush out the stored heat. Air faces physical resistance as it moves through the pile, increasing sharply with grain depth. To maintain airflow, vent acidity must match this specific depth and volume. Operators also monitor external temperature and humidity, ensuring the introduced air actually cools the crop. Successful aeration is an engineering challenge that balances physical depth, mechanical power, and environmental timing. A properly designed aeration system equalizes temperatures across the entire bin and flushes out the trapped heat. By removing that trapped heat and significantly reducing internal condensation, the system stalls insect development and neutralizes mold growth. However, aeration cannot improve the quality of the grain itself. The fans act as a time capsule, preserving the exact quality the crop possessed at the moment of harvest. Grain aeration is the essential tool that extends the safe life of our harvest and protects the feed value of the global food supply.